All right, folks, I'm going to get started. Welcome back, everybody. Actually, now I'm going to get started. All right, welcome back, everybody. Welcome to the last day of the second week of class. So we are an eighth of the way done with the quarter after today, or semester after today. So I hope that makes you feel good. We're moving along. Things are getting done. Make sure that you are taking this seriously at this point. You got off vacation. You had a few days to kind of ease yourself into this, but by this point, you have to be in. Like, this is it. You are in school. There is stuff to be done. It's not time to run away from it. It's not time to put things off. This is the opportunity to really take advantage of, the free time that you have that is not pressing yet, right? You're not being backed into a corner just yet. There aren't exams like being piled up upon you. There aren't assignments coming at you left and right yet. So it's not the time to kind of just like ease on into the semester. It's the time to say, okay, what can I get done now that'll allow me to have time for the other things later that I won't have time for? And then get those things done. And then when the pressing times come, you get those things done the right way. And then you walk away from the semester feeling good about what you did versus feeling beat up and just like maybe you're not even good enough to deal with this whole experience, which is silly because all of you are more than capable of overcoming this class, any other class. And again, it's about how much you put into it. So that's the mentality you should have from the get-go, from the beginning, not in the middle, not right before exams. Like the week before the exam, I'm going to try really hard, and then between exams, am I going to do anything? Is that the right approach? No, it's not the right approach. You are in school every single minute. You are a student. That is who you are. That is what you are. You work sometimes to make some money. That's not as important as what you do here. You have time that you want to spend with your friends, your family, etc. That's important, but not as important as what you do here. This is the most important thing you do. This is what you do. And then everything else is what you can do when you have time for it. That is the mentality you should have. You signed up for this. You're paying for it. Like I said, this is something that you have decided to do. Nobody is forcing you to do it. You aren't being forced to take this class. You aren't being forced to do anything. You are choosing to do it. Choose to do the right thing. You're not in high school anymore. You're not being herdled around like cattle, being kept prisoner for like 8 hours a day. That's not what this is. And if you've carried the mentality from high school into this experience, then you've made a mistake. This is not the same experience. Nobody is making you do anything. You need to be engaged in this process versus there where it's like, it's like the limitations of that experience, like they tend to numb you and you tend to just be like, whatever, I'll just like let them push me along this whole silly thing that you've come up with to force me to learn. That time is over. This is a completely different thing. Your mentality needs to be different with respect to it. I hope you have evolved your mentality, and you haven't, work on it. Think about it. Change the way you think about this. That'll change your overall approach. It'll change who you are. It'll make you better. It'll get you more ready for what you actually will be challenged to do, which is survive in the world and ultimately thrive in the world, if that's what you want, which is what we all want. We all want to like be able to be the best we possibly can be in this very complicated, competitive society we live in. So this is the time to get ready for that. You will never have another opportunity like this again, so think about it. All right, regarding people that are trying to get into the course, people are not dropping out of the class, folks. Like, it's unfortunate, but that's just the way it is. But there are still about 13 days, or no, 10 days, about 10 days left of add and drop time. So you never know. People could still drop out of the course. So you are free to keep coming. But again, you have to keep coming just to be in the running for a spot. As of right now, let's see, 3:10. Okay, Fatima. Okay, so you will definitely get in. All right, but later next week. Rajminder Tour, out of the running. He was second. He would have got in. Bam, out. Fourth one, Boyan Lee. All right. So if Rajminder doesn't show up within the next 5 to 10 minutes, you're pretty much in. So, but it won't happen until like the end of next week. Okay. And then finally, Bryce. Bryce, somebody has to drop out for you to get in. That's the only way I can let you in. And that's it. So there's just 3 of you. I wish you the best of luck. Bryce, really. I can't let more people in than 2 beyond the seating capacity. That's why I said they can get in. And beyond that, my hands are definitely tied, unfortunately. So anyway, so that's that business. Anyone have anything you want to ask me? Anything you want me to address before I get into the material? All right, cool. So you saw I opened up chapter 1's homework and mini paper today. When we finish chapter 2, I'll open up chapter 2's homework and mini paper. Actually, I'll do everything for this class that I would normally do on Thursday night by 5 o'clock the next day. So within a day, I will do everything. It's just I have other responsibilities, and sometimes I won't be able to get to uploading stuff and opening up assignments. If that happens, like I mentioned, I'll give you an extra day for the assignments, whatever. So don't worry about that. But I will try. So like tonight, I'll try to get everything up if I have time and mental capacity, because I have to sleep. So anyway, that's that. Question? No, by the middle of the 3rd week. Yeah. So all assignments these first 3 weeks won't be due to the middle of the 3rd week because of add drop stuff. But beyond that, assignments will be due, as I mentioned in the syllabus, Sunday nights for homeworks within a week of finishing a chapter for a mini paper. But I'll make slight adjustments to that depending on what's happening in the class. But those will be the general rule for stuff. Chapter 1 I did. Chapter 2 I'll open up by 5 o'clock tomorrow, once we're done with chapter 2 today. And just remember, though, like the assignments are not that complicated. They're just they're 10 multiple choice questions, and the true false do come from those. So it's important for you to know those, and they reflect some of like the principles, the ideas that underlie a lot of what we do. But ultimately, what you are really going to expect it to do, and what is going to make up the majority of the exams, are the problems, the practice problems, right? So they're called practice problems because you should practice them and understand them, be able to do them, as well as maybe a slightly different versions of them. Not tricky versions, but like versions maybe that have different numbers and slightly different scenarios, but the same mathematical logic. So that is also your homework assignment, to be going through the problems that I present. Make sure you understand how to do them. Make sure you know all the math steps, because you will be expected to do them. And as I said, you will be allowed calculators for the exam, but only a scientific calculator, no graphing calculators, no phones. And I'll remind you of that before the exam, of course. Other questions? Alrighty, let's move into the rest of chapter 2. So we're going to finish chapter 2 today. We started last time, supply and demand. So we're talking about, I think we covered both sides of the market. We covered equilibrium, and we covered price controls. So when the government comes in and says, hey, the price is too high, the price is too low, what that means, how it looks with respect to the market. Today we'll talk about the determinants of supply and demand, what will shift the supply and demand curves, what will affect either side of the market other than the price in the market. Anytime you have a price change on the supply side, then you have a movement along the supply curve. You have a price change on the demand side, you have a movement along the demand curve. Those are described as changes in quantity demanded and quantity supplied. But if something else is changing in the market, we describe that as a change in demand or a change in supply, right? The entire curves are shifting. And then we'll jump into the algebra of supply and demand. And then we'll also look at the appendix that asks, how do taxes affect equilibrium prices and quantities? And we'll also do a little bit of algebra there as well. All right, so the determinants of supply and demand. So there's certain things that will shift demand, that will shift that relationship between price and quantity embodied in the demand curve. We focus on the main ones in this course, but there's others, and they can affect demand, but these are the main ones. The ones I will mention are maybe going to be slightly different from the ones you see in other books, because again, there are other things that can shift demand or supply, but you should you should just understand how to kind of do the analysis. Like if something is changing, who's being affected, and then like in what way, and then is that increasing or decreasing demand or supply? So let's go through these in turn. So the first one is incomes. Obviously, income will affect demand, and it will depend on the nature of the good in relation to how a person views that good. So if you view the good as what's called a normal good, then demand will increase when incomes increase and vice versa. So basically, anything that you would buy more of as your income goes up is a normal good, and anything you would buy less of as your income goes down is a normal good. So luxury goods tend to be normal goods in general. People buy more of them as their incomes go up, buy less of them as their incomes go down. And that's in contrast to the other case with respect to incomes, which is an inferior good. So an inferior good is a good that folks subjectively will think as a good that they will buy less of as their income goes up, or buy more of as their incomes go down. So if you think about like just crappy like frozen dinners, like crappy frozen dinners, really cheap, right? You can go to the 99-cent store and get a bunch of them if you need to. If you're on a fixed income, you're going to buy crap like that just to survive. But as your income goes up, you're going to buy less of that stuff. So those are inferior goods based on what you think or what I think, or maybe you don't think that. Maybe I just think that. I do, though. I do think that. They are crap. But the term inferior is not universal. It's subjective. Whatever you consider to be an inferior good, whatever a consumer considers to be an inferior good, because as their incomes go up, they buy more, and vice versa, is an inferior good, right? So there's no like blanket definition that you can use to describe one set of goods as inferior versus another. It's very subjective. But as long as you understand what it means, what an inferior good means, and what that means with respect to demand, then that's enough. All right, tastes. How people in general feel about the good. What that might be based on like cultural reasons, or because of like the zeitgeist, the general sort of ideas that encompass a period of time, what most people are thinking about certain things. So the zeitgeist has changed with respect to bicycles, right? Over time, fuel efficiency has become more of a priority in our society, and so people have become more willing to buy bicycles. So at any given price, demand has increased for bicycles. People are willing to buy more bikes at any given price. All right, the price of related goods. The related goods to a good we're analyzing could be one of two cases. Either they are related as complements, meaning they are bought together. So complements are two goods. Two goods are complements if a rise in the price of one good leads to a decrease in the demand for the other good. So if two goods are bought together, like peanut butter and jelly, they're complements. If the price of peanut butter goes up, then quantity demanded of peanut butter goes down. People buy less of it. It just reflects the law of demand. But people will also buy less jelly as well in the United States, because culturally, that's what we like. We like peanut butter with our jelly. So at any given price in the jelly market, because the price of peanut butter has gone down, people will buy less peanut butter. So the demand will decrease, so it'll shift to the left. The other possible case is that the two goods are viewed as substitutes. So substitutes are goods that are bought in place of each other, right? So as the price of one goes up, you buy more of the other. As the price of the other goes up, you buy more of the one. So two goods are substitutes if the rise in the price of one good leads to an increase in the demand for the other good. So let's say Coke and Pepsi are substitutes. So if the price of Coke goes up, you substitute to Pepsi. So the demand for Pepsi increases. If the price of Pepsi goes up, and this is the Coke market, then if the price of Pepsi goes down, and this is the Coke market, then the demand for Coke will go down. At any given price, people will buy less Coke because the price of Pepsi is now lower, so people have substituted away from Coke to Pepsi. So it just depends on whether the related good is a substitute or a complement, and of course your understanding of the distinction between the two cases. Expectations. So what a consumer expects to happen in the future will affect their consumption today, right? So let's say that in a month they're going to lower the price of that video game system. that you were planning to buy. And everybody else knows it as well. So today, at any given price, demand will decrease, right? Demand will shift to the left because people know that in the future they can buy at a cheaper price. So they expect prices to go down. So their consumption today, their demand decreases. Or another thing that could affect your expectations is income, right? So there's a big financial crash like in 2008. So you expect people to get laid off. That means there's going to be less production in the economy. That means incomes are going to go down. That means your income may go down. Your job may be in peril. So at any given price, you're going to buy less of everything, right? So your demand will decrease because you expect your income to decrease in the future. So expectations play a huge role in markets and ultimately in economic analysis. They are probably one of the central components of why economic analysis is so complicated. Ultimately, we have to use a lot of different tools, including probability, because you never know how people are going to feel about things with respect to like what they expect about the future, given a variety of things that might be happening, right? So when we're trying to model like the path of a price over time, and there's just certain things happening that tell you, oh yeah, those kind of things usually lead to price increases, but people for whatever reason change the way they react to the expectation, and that actually leads to lower prices rather than higher prices, then that can totally throw off our models. And so, because expectations are such a subjective thing, and we try to sort of control subjectivity by imposing objectivity into our calculations and our models, then you're sometimes going to have some error there that is going to create uncertainty about what we do in general, our approach in general, how good it is, how effective it is. And so that's why economics winds up being an art rather than a science. If you get a degree in economics, it's a degree in the arts versus in science, because there is this sort of area that we cannot account for versus like physics, where it's like you can say, oh, the mass and gravity or whatever will lead over time for a sun to develop and for this many planets to start orbiting it, given the amount of extra whatever that exists around that body in the universe. You can actually predict that will happen in a model, and then you can see it in nature. It actually happens that way. So there's a more concrete sort of relationship between the models and other, like the physical sciences, and what they're actually studying versus economics, where again we're dealing with people as sort of like the heart of an economy, and people are, we sometimes do behave logically, but sometimes we act a little crazy, right? Sometimes we'll vote for the nut to run us. Sometimes we will vote to exit trade unions that are really beneficial to both us and the entire world. Why? Because it's like, that's just like, there's no rhyme or reason to some of the things we do individually as well as collectively, and that creates a complication. So we have to take into account expectations. We do our best to say what those expectations might lead to in our models, in this case the demand side of the market, but ultimately people are going to do whatever they're going to do, and things are going to go however they're going to go. All right, population, though, is something concrete that we know will increase demand if it goes up in a particular market, and will decrease demand if it goes down in a particular market. So if you think about the baby boom generation, post-World War II, a lot of folks died, everyone came back, and they're like, we need more people. So they made a lot of people, a lot more than they had. That generation, huge, moved through time in the markets for baby products. Demand increased when that generation was babies. When they became college age folk, demand for education increased. At any given price, people were demanding more education. Now these people are retiring. Medical services, at any given price, there's going to be an increase in demand because there's just more people in the markets for those goods. All right, let's talk about the other side of the market, supply. So again, there's going to be certain factors that will shift the supply schedule, our demand curve. which again, mathematically, when we're talking about what we're looking at graphically, we're talking about an inverse supply function because it's price as a function of quantity supplied, whereas the actual relationship is quantity supplied as a function of price, which is the supply function. Anyway, so improved technology. So a lot of what shifts supply has to do with cost, right? So if technology improves and thus you can produce more within any given unit of time, then you're going to supply more at any given price because now it's cheaper for you to supply. So over time, the last 2 centuries, we've had several industrial revolutions, right? The first couple had to do with like steam power and then electric power, internal combustion engine, introduction of steel. These things dramatically increased our ability to produce because we mobilized, we were able to achieve a scale that we were never able to achieve before. Scale reduces costs. So that improved, and now of course the digital revolution that has severely increased the speed at which we can communicate, which lowers costs as well. Transaction costs are so at any given price, as our technology improves, suppliers are willing to supply more because their costs go down. So supply increases as a result of an increase in technology, an improvement in technology. Higher wages. So again, we're talking about the cost of production. So what we're really talking about is factor prices here, the factors of production. That's what factors are generally thought of as in economics, right? So the 2 main that we'll talk about in this course, we'll use two categories to define our factors of production. One is labor, the other is capital. Capital will embody like everything else used to produce, but generally we're talking about like people-made things like factories and machinery, etc. So if the cost of any of those things goes up, obviously at any given price, suppliers will supply less. And so therefore supply will decrease or the supply curve will shift up, however you want to describe it. So higher wages will do that. Lower wages will increase supply. Lower interest rates. So the cost of capital is what we call the rental rate. So the cost of labor is the price of labor is the wage, and the price of capital we assume in economics to be the rental rate, which we'll talk about later at the end of the chapter when I talk about capital specifically in one of the final chapters. But lower interest rates fall into is one of the components of the rental rate, and basically what it captures is like the opportunity cost of investment resources. So if interest rates go up, then your opportunity cost of investing is going up. You could be using the money you're investing to produce to just invest in an investment vehicle like a bond or whatever and get a higher return. And so higher interest rates will tend to lead to a decrease in supply, whereas lower interest rates will tend to lead to a increase in supply. If the interest rates are going down overall in the economy, that means investors can now pull their money out of investment vehicles and make a higher return by actually producing. Investing means buying physical capital to produce. Higher prices for raw materials. Raw materials are also factors of production. We'll just throw them into the capital category in this class, but of course you need like raw materials. So if your raw materials go up in price at any given price, you're going to supply less, and supply will decrease because your costs have gone up, and vice versa. Number of suppliers. So like I mentioned last time, one of the 2 functions of price. One function of price is the allocative function of price, and that's meant to allocate these scarce resources to those that value them the most, right? And so the other function of price is to kind of guide like the investment resources into those areas that yield the most profits. And so if there's an industry where profits are obviously being made, then the resource holders, those that can invest, will shift their resources away from a less productive activity to a more productive activity. So when they do that, there will be an increase in the number of firms. That means that at any given price, firms will supply more. That means supply has increased. The supply curve has shifted to the right. Expectations, again, will play a role on the supply side. If producers expect prices to go up tomorrow, then today they're going to supply less because they know that tomorrow they can sell for higher prices. So at any given price, if they expect prices to be higher tomorrow, they will supply less today, so supply will decrease as a result. And vice versa. If they expect prices to be lower tomorrow, they're going to increase supply today at the higher price. Ultimately, it's all about profits for the suppliers, so you always have to think about that when you're thinking about the supply side and how things are affecting it. How are the conditions affecting the profits? So weather is another thing you can throw in there. Obviously, good weather, like especially in agricultural industries, if there's good weather, then at any given price, you're going to supply more because you got maybe a lot of rain, a lot of water that's obviously free, and your costs have gone down. You can supply more. Bad weather, vice versa, maybe wiping out whole crops, wiping out capital, raising your costs. Therefore, you're supplying less when there's bad weather. Yeah.
So you said there's lower interest rates, so people pull their money out to invest in things to produce. So is that why there's also many tech companies and IPOs and everything like that? Because a lot of people will see a higher return on their investment.
That's partly why, yeah, because interest rates have been very low for like the last 10, 15 years. So that's partly why, yeah. But obviously that's not the whole story, but yeah.
So let's say that you're a farmer and you have crops. You have horrible weather and still your supply goes up.
No, bad weather, your supply goes down.
Okay.
Yeah. Was there another hand over here somewhere? All right, quick economic naturalists. Again, I mentioned I would cover a couple of the economic naturalists at the beginning of the book, but as we go further on, I won't talk about them. I'll just expect you to read them and decide if you want to write about them or not. But this one in chapter 2 has to do with why the prices of some goods like apples go down during the months of heaviest consumption, while others like beachfront cottages go up. So the answer is that the seasonal consumption increase is the result of a supply increase in the case of apples and a demand increase in the case of cottages. So here is the market for apples. Here is a market for beachfront properties. The subscripts W and S in the figure are used to denote winter and summer values respectively. So here's our supply in the winter. Here's the supply in the summer for apples. During the summer, the supply increases because weather's better. So at any given price, supply moves to the right. Suppliers are willing to supply more. So if we were at this equilibrium before, when supply shifts to the right, you've got this amount of demand and this amount of supply. You're going to have excess supply at that price. These suppliers will start lowering their prices. These consumers will enter the market who had a reservation price below the price before that weren't and therefore not willing to buy. And so they enter the market. These suppliers exit the market because their costs aren't being met as the price is decreased. And so then we get back to the point where quantity supplied equals quantity demanded, a new equilibrium for the market. In this case, the equilibrium price has gone down, equilibrium quantity has increased. For beachfront property, things are different, right? For beachfront property during the summer, demand increases, right? People want to go on vacation. People want to rent cottages on the beach. So at any given price, and that's like a taste thing, right? It has to do with tastes during one season versus another. So tastes will change during the summer, and thus at the old equilibrium, when demand increases, you're going to have a price that's going to correspond to this amount of supply and a lot more demand. You're going to have a shortage of demand, a shortage of the good there, right? So when there's a shortage of the good, these people start to bid up the price, more suppliers enter the market, and then you get to a new equilibrium. In that case, a higher price versus a lower price in the case of apples, but both do lead to an increase in equilibrium quantity. So when demand increases, that's going to have a different effect than when supply increases. And so just understanding that that different sides of the market can be affected by different forces. We'll explain how prices can fluctuate in different markets for different goods, right? That's ultimately what this is about. You can come up with different cases. You can just expand on these, talk a little bit more about actual prices in these markets, do a little bit of research, whatever. Write a 2 to 3 page paper. You're done with a mini paper for chapter 2. All right. And as I mentioned earlier, there is that descriptive sort of distinction between a movement along the curve and a shift of the curve. I may not have mentioned it, but I'm going to mention it again if I did. If not, I'm mentioning it for the first time. Anyway, I had to be thorough. Anyway, so if we're talking about a movement along the curve, we're talking about a change in either supply or demand versus a shift of the entire curve. I'm sorry, we're talking about a change in quantity demanded or change in quantity supplied. We're talking about a movement along the curve. The only thing that can cause that is a change in the price. If anything else is affecting either side of the market, we are talking about changes in demand or changes in supply. The quantity is not included there, so we can distinguish between either a movement along the curve or a shift of the entire curve. So again, when economists use the expression change in demand, they mean a shift in the entire demand curve. When we say change in quantity demanded, we mean a movement along the demand curve. The same distinction exists on the supply side. The terminological distinctions are important for clear communication both in classroom discussions and on exams. So just be able to clearly communicate what we're talking about. And just one last way of highlighting the distinction. Again, change in demand. At $1, people were willing to buy 10. At $1 now, people are willing to buy 15 because incomes have gone up, let's say. That means that at any price, people are willing to demand more. The entire curve shifts. That's an increase, a change in demand. In this case, it's an increase in demand. Versus the price of the good was $1. People were willing to buy 10. The price of a good went down to 50 cents. People are willing to buy 14.2. So we just moved down the demand curve. That means quantity demanded has increased in this case. And same distinction for supply, change in supply. Again, increase in supply moves to the right, decrease in supply moves to the left. Change in quantity supplied, depending on the movement. If you're moving up, you're increasing quantity supplied, moving down, decreasing quantity supplied. All right, quick practice of sort of identifying what happens to equilibrium, price and quantity when there's some change in the market. So you have to be able to say, which side of the market is being affected by the effect, and then what's happening to equilibrium, price, and quantity. So let's do a couple of practice problems focusing on that. So you've been hired as a consultant for a big cola producer. Your client wants you to predict what will happen to the cola market in each of the following scenarios. New research shows that cola is addictive. Is that going to affect demand or supply? Demand, right? And what is being affected there? Health. What's affecting your choice? It's your taste, right? Your tastes are being affected because now you know that cola is addictive, whereas before you just thought it was delicious and not addictive. Now you know it's addictive and delicious. You might keep eating it, or drinking it, but most people will not, right? What's going to happen to demand? Is it going to shift to the right or to the left? It's going to shift to the left, right? So if demand shifts to the left, is it going up or down? It's going down, right? So if you think of demand this way and it shifts to the left, it's moving down too. It's just different ways of describing it. So demand, yes, the demand curve will shift down. Demand has decreased as a result. Tastes have shifted out of favor for cola. It's the opposite of what we see here. So here's the market for Coca-Cola. There's our equilibrium price and quantity. What's going to happen to the equilibrium price? It's going to go down, right? What about equilibrium quantity? It's going to go down also, right? So demand will decrease at any given price. People will demand less cola. And so we see that our new equilibrium corresponds to a lower equilibrium price and a lower equilibrium quantity. So let's say on an exam, if I were to ask you questions like this, if you can't think it out in your head, just draw it out for yourself. Make sure you get the axes right, because that's a point that generally people overlook and tends to lead them to the wrong answer if you don't remember that price is always on the y-axis and quantity is always on the x-axis. Anyway, there's that one. Your client spends $80 million on a marketing campaign. Is that going to affect demand or supply? It's going to affect demand, right? So we didn't talk about that as one of the things that shifts supply. Obviously that could, but like just focus on the things we talked about. The most effective thing that this will do is to change people's tastes, right? Effective marketing will change people's ideas about goods in general, right? Maybe not everybody, but in general. So then what's going to happen to demand? It's going to shift up, right? The demand curve will shift up. Taste will shift in favor because of advertising that's effective. What's going to happen to equilibrium quantity? It's going to go up. What's going to happen to equilibrium price? Up as well, right? Demand curve shifts to the right. Equilibrium price goes up. Equilibrium quantity goes up as well. The government imposes a higher price floor for corn. So remember, a price floor means that the price cannot go below a certain price, right? Is that going to be below or above the equilibrium price? It's going to be above, right? Because below it, the price wants to go up, right? So if you say the price cannot go below this price, it's meaningless, right? It's not binding. It's a non-binding price floor. But if the price floor is above, then it's going to be effective. And that means that the price floor is now going to do what to the producer's costs? Increase the cost, right? The price floor is now higher, right? So what's going to happen to the supply of cola? Yes, cola. We're still talking about the market for cola here. Corn syrup. It's going to decrease supply, right? Supply will decrease, right? So the demand curve will shift up or down? It's going to shift up, right? It's just upward sloping. So when it shifts to the right, to the left, it actually shifts up, right? You just got to keep it in order in your head. So yeah, the supply curve will shift up. The price for raw materials has gone up, right? So here's the market for corn, right? There's a price floor. It's set above equilibrium at a price floor. Quantity supplied is greater than quantity demanded. So obviously there's going to be a surplus. The government has imposed a higher price floor, right? So now it's even higher than it was before. In the market for cola, that means costs have now gone up. What's going to happen to equilibrium price? It's going to go up, right? What's going to happen to equilibrium quantity? It's going to go down. Be very careful. So yeah, costs have gone up. Supply will decrease. That's going to lead to a higher equilibrium price and a lower equilibrium quantity.
So when we're talking about shifts, you want to talk like say reference up and down rather than left and right.
It doesn't matter as long as you understand what's happening. So you can describe it either way, as long as you're describing the right direction and the right effect on the equilibrium. But you have to understand that you can describe it in different ways, and so you might come across it being described differently in different contexts. You just have to know what they're talking about, right? All right, what's next? Two big companies enter the market for Sprite. So think about what happens for Sprite. Okay, go ahead. Okay, so yes, right? In which market? For Sprite, right? We're talking about the market for cola, though, right? So think about, okay, so two big companies enter the market for Sprite. So they're both entering the market to create something very similar to Sprite, right? So what's going to happen in that market for Sprite? Supply will increase. There's new producers, right? There's more producers in that market. So if supply increases, right? Here's our supply curve, right? What happens to price? It goes down, right? What's going to happen in the market for cola? Who's going to be affected? Demand, because it's a substitute. Exactly. So what's going to happen to demand? Yes, it's going to decrease, right? So demand will decrease, right? So here's demand, it'll decrease. All right, so yes, So the demand curve will go down, demand will decrease. The price of a substitute in this case has fallen, and there's an increase in the number of firms in the Sprite market, right? So here's the market for Sprite. Supply has increased, equilibrium price has dropped. Now people that drink cola are like, I can drink Sprite for a lot cheaper. So they're going to substitute away from cola to Sprite. So in the market for cola, the demand will decrease and equilibrium price will fall and equilibrium quantity will fall as well. I promise not to be too tricky. In fact, I won't be tricky at all. It'll be very straightforward. But, it's just good to kind of like work through these problems and just kind of figure things out. Like, how are things related? Is one thing affecting something else? What is the complexity of an effect of a shifter on a market, and how does that relate to other markets, etc.? All right, the top secret formula for Coca-Cola gets leaked to the press. It doesn't have anything surprising in it. Is that going to affect the demand or supply in the cola market? Supply, right? Because now, even though it doesn't have anything surprising in it, yeah, other companies can make the exact same thing now. They know exactly what's in cola and Coca-Cola, right? The king of all colas, right? The secret formula is out, and now anybody can make it, even though everybody kind of knew what it was already. But now, definitely, more firms will enter the market, and so supply will increase, right? Supply curve will shift down because, again, it's positively sloped, so when it moves to the right, it's kind of moving down. So increase in the number of firms, supply moves to the right, supply increases or moves down, however you want to describe it. Market for cola, we see equilibrium price falls, equilibrium quantity increases. All right, so that's that. Hope you guys got that, and play with that. Make sure you can basically just understand the shifters. Understand what the main shifters are of demand and supply. If you understand that, then if I tell you something's happening in a market, you should be able to include it into one of those, and then you can, in your mind or in a drawing, kind of figure out what's happening to equilibrium price and quantity. And then you're good on that type of problem. All right, the algebra of supply and demand now. The examples thus far have focused on the geometric or graphic approach to market equilibrium. For actually computing numerical values, it's usually more convenient to find equilibrium prices and quantity algebraically. So suppose, for example, the supply schedule for a product is given by the linear inverse supply function. So inverse supply function, what variable is a function of what variable? Price is a function of quantity supplied, as we saw it on the graphs that we learned in our introductory courses. So here is an inverse supply function. Price is a function of quantity. Price equals 2 plus 3q superscript s to denote quantity supplied. And its demand schedule is given by the linear inverse demand function. So here we have, again, price as a function of quantity. In this case, quantity demanded, because we're talking about the demand side of the market. The positive slope on the quantity variable reflects the law of supply. As price goes up, quantity supply goes up. The negative slope on the demand function reflects the law of demand. As price goes up, quantity demanded goes down. Again, P is the product price, and Q and S stand for the quantity supplied and quantity demanded, respectively. The inverse designation refers to the fact that price is a function of quantity. In equilibrium, we know that quantity supplied equals quantity demanded. Denoting this common value as Q star, so in equilibrium, these quantities are equivalent, so we'll just denote them as Q star. We may then equate the right-hand side of equations 2.1 and solve. So essentially, here we've got two equations. We've got two variables we need to solve for, price and quantity. A system of equations is all you have. You've done these in algebra. To solve any system of equations, you need as many equations as there are variables. If you don't have that, you won't be able to solve that system, but we do have it here, so that's not a complexity. So like any system of equations, you want to plug one equation into the other in order to get it into one get the equation into one variable, have only one variable in that equation, be able to solve for that one, and then you can plug it into either equation to solve for the other variable. So here, if we plug in this one, so we plug in P equals 10 minus Q into this P, essentially setting them equal to each other. So then you've got 2 plus 3Q equals 10 minus Q. And now it's just algebra, right? You want to combine like terms. Like terms are those terms that have the same variables in them. So in this case, the Q's have the same variables. 10 and 2 are constants, so you want to combine those. And then you want to isolate your variable to solve for it, right? So initially, I'll go through every step with like algebra and anything else we do, but eventually I'll stop doing every single step. But just to start off the course, I'll be very specific about every step because there might be people that are rusty on the math and just need some reminders of how to do these steps because they haven't done them for a while. So you just have to be patient. If those of you that are more advanced in math, and again, those of you that aren't advanced in math, don't feel bad. You can get really good at math. Math proficiency is a function of how much math you do. The more math you do, the better you get at it. If you just believe you can't do math, you're not going to spend time doing math, you're not going to get good at math, and you're going to actually reinforce your silly belief that you are incapable of doing math, which is, as I said, silly, because you are fully capable of being exceptional at math, at biology, at like the hardest disciplines you can think of. You can be exceptional at those. It just requires a hell of a lot of time, and you should be willing to dedicate that time to it if you want to be great at anything. Anyway, so let's do the algebra here. We're going to combine our like terms, so I'm going to get the constants on the right. So here I subtracted 2 from both sides. And I'm going to get this Q on the left side to combine it with this 3Q, so I added that to both sides. These Q's drop out, these 2's drop out. We're left with 3Q plus Q, which is 4Q on the left. 10 minus 2 equals 8 on the right. And now I just want to isolate my variable. I want to divide both sides by its coefficient, so divide both sides by 4. And then you get the equilibrium quantity in this market to be 2 units. And now you just take those 2 units, Q equals 2, you plug it into either of your inverse demand or inverse supply functions to get the equilibrium price, right? So substituting Q star equals 2 back into either supply or demand gives the equilibrium price. So P equals 2 plus 3 times 2. So this is our inverse supply function. So I plugged in Q equals 2 into it. So you have 2 plus 6 equals $8. Another thing to remember with math is the order of operations. Please excuse my dear Aunt Sally. So parentheses, exponents, multiplication, division, addition, subtraction. So always do the math in that order. If you don't, you're going to get the wrong answer. So just remember that. Please excuse my dear Aunt Sally. It usually is a good mnemonic device to kind of help you remember that order of operations. All right, graphing equations 1 and 2 leads to the same solution. We have found our equilibrium in the market. The equilibrium quantity is 2. The equilibrium price is 8 there. And for those of you looking for a bigger challenge than the simple math, you're going to get it. Don't worry. It's just one step at a time here. All right, the advantage of the algebraic approach is that it is much less painstaking than having to produce accurate drawings of the supply and demand schedules. All right, let's do another practice problem, this market equilibrium problem. So Yellow Cab has conducted a number of pricing experiments and estimated that the daily demand for taxi rides in the city of Santa Cruz, where I used to live, can be described by the following demand function. So again, here we're looking at a demand function because quantity demanded is a function of price, right? Quantity demanded is the dependent variable and price is the independent variable in the way we've specified this relationship. And so we're looking at a demand function as opposed to an inverse demand function where you would have price as a function of demand of quantity, which is what we had in the last example. All right, so just so that you have some practical knowledge about where these functions can come from. First you establish the relationship between the variables. You know that quantity demanded is affected by price. And then to get these actual numbers, like the constant for the equation and then the slope parameter for the price, you do a statistical analysis. So you can do an analysis of a market and look at how much quantity demanded is changing with respect to changes in price. you throw that into an Excel sheet. You do a regression, which is like a statistical technique, and then that'll estimate for you these numbers. So you can go from real world data to this kind of equation pretty easily if you have the right data information and you know the right methodology. It's stuff that you can learn via an econometrics course or just a basic statistics course. Just some knowledge to help you sort of understand that we don't just do math in this class for the sake of math. Like, it means something. You can actually use it in the world to figure things out and solve problems and improve situations. So keep that in mind. We're not just doing math for the sake of math. Also, models are meant to help us understand things. And generally, when we're modeling relationships in economics, we're being very general about it. But like the numerical examples are meant to sort of guide us through the logic of the model. So if we can work through the model numerically and understand how to get from the equations to like the results that have some economic meaning, then we will process the logic that underlies the relationships better. And so that's why we go through numerical examples. If you ever go further in economics, you will see that, and even in finance and any field that uses ideas from economics, you will see that the models are very general. They're expressed in variables and in like Greek letters to represent like parameters that affect the variables. But even in the most complicated models, in the most advanced applications, you will always have like simple numerical examples to sort of highlight the basic logic that underlies the relationships that are being studied. So there is a practical reason for everything that's done in this course. It's not just about torturing you. So just keep that in mind as we move through the course and start to mount up the amount of different models and different numerical approaches we take to understanding these economic relationships. It's easy to just get caught up in like the minutia of the volume of the work that you're expected to do and how unrelated they may seemingly be. But ultimately, there's a rhyme and reason to this. You got to keep that bigger picture in mind or you will get lost and you will lose motivation. Don't let that happen to you. All right, so here is our demand function. So Santa Cruz has estimated this. So they've done a number of pricing experiments and estimated via their statistical approach this demand function. P is the average price per ride. How many rides will be requested at a price of $20? How do we figure that out? Plug in P equals 20, right? So plugging in P equals 20, multiplying these first, and then subtracting that from 51,000 gets us to quantity demanded equals 3,000. The Santa Cruz Chamber of Commerce surveyed all transport operators in the city of Santa Cruz and estimated that the cost of the average daily taxi ride follows the following inverse supply function. So here we have an inverse supply function, price as a function of quantity supplied. How many rides will be offered at a price of $20? So here, again, you plug in price equals 20, right? And we're trying to figure out quantity supplied. So plugging that in, subtracting 9 from both sides, and then dividing both sides by 0.00833 gets us to quantity supplied to be 1320. What is the excess demand or supply in absolute terms at a price of $20? So we figured out what quantity supplied was. We figured out what quantity demanded was. We know that at a price of $20, that 3,000 taxi rides are being demanded. We know that at a price of $20, 1,320 taxi rides are being supplied. So do we have a surplus or a shortage? We have a shortage, right? So there's a shortage here of taxi rides. So how do we figure out how much that shortage is? We subtract 1,320 from 3,000, exactly. So 3,000 minus 1,320 gets us the excess demand here, which reflects our shortage, and it's 1,680. 1,680 rides at a price of $20. So we're below equilibrium. All right, so we're going to figure out what the equilibrium price is. Obviously, it's going to be higher than $20, right? So we're going to do exactly what we did in that last problem. But in this case, we don't have two inverse demand functions that can just be set equal to each other. Two inverse functions that can be set equal to each other. So you just like either plug in P equals this expression into the P there, and then do some algebra, or you can plug in Q equals 51,000 minus 2,400 P into Q here, and then solve for P in this. Either way will work. We're looking for the equilibrium price there. So here's our system of equations. Again, we're looking for equilibrium, so we're going to assume that quantity supplied equals quantity demanded, so it just equals Q in this case. I didn't put the star in there, but whatever. As long as you're consistent with notation within a problem, you're good. So in this case, I chose to plug in my demand function into my inverse supply function by plugging in Q equals 51,000 minus 2,400 P into Q there. Please excuse my dear Aunt Sally. So parentheses, nope. Excuse, no exponents. My multiplication, yes. So we need to multiply this out. So P equals 9 plus this times this, and then this times this, right? You want to distribute that. So you're going to get 424.83 by multiplying these two, and then minus 19.992p by multiplying these two. Like terms, we'll combine those. And then we want to get the p's together. So I'm going to get this term on the left-hand side by adding that to both sides. Combine these p's over here. That gets me 20.992p equals 433.83 on the right. Divide both sides by 20.992 to isolate my price variable. And that gets me to my equilibrium price to be $20.67. Just 67 cents above what it was before, but we see that at that price, quantity demanded and quantity supplied will equilibrate in this market. What time do we start this class? 2, okay. All right. I don't know. I've got classes. I don't know what time. I don't know what day it is. It's just the way it goes. Oh, thank you. It's Thursday. Great. All right. It is great because now I have a 4-day weekend to get a lot of work done. Because I do work every single day, a lot. But I don't have to be here. Anyway, all right. So that's my equilibrium price, right? Now we're going to solve for equilibrium quantity, or I think price might be all that we were solving for there. So that's our price, 20.67, again, corresponding to that point where the supply and demand curves intersect. Next question, what is the equilibrium quantity? Now I'm going to plug in that price into one of my equations. It doesn't matter which one. So I plugged it into my demand function there, 20.67. I'm going to multiply this term, then subtract it from this term, right? And my equilibrium quantity will be 1392. Another important note. 2 things, actually. One, even if you're really good at math and you are quick at stuff, you have to be careful because you're not just doing math, you're doing economics. So you can screw up easily. You can miss a step. So don't get too overconfident. Take your time. Think about each step. Make sure you just kind of list it all out for you so that you're sure you're doing the right thing. Even if you're really good at this stuff and you're used to doing a lot of certain things in your head, don't do it. Because again, during an exam, exams are timed, and you might be rushing and you screw up an answer and then it all goes out of whack. But I do give partial credit. And also with respect to rounding, I don't have any conventional approach to it. So if you round to 2 places versus 4, I don't care. Yes, your answer will not be exactly like mine, but it'll be within a range of mine. As long as I see you've done the right thing, I'll give you the full points for it. Yeah. What do you mean?
I'm assuming you plug in numbers online.
You don't. No, it's just like multiple choice. Yeah. It's pretty simple. Just kind of walking you through your understanding of like principles stuff. There might be some problems. I forget if there are, but in the end, it'll just be multiple choice again. Yeah. So it's not about plugging in stuff and showing your work and stuff on that homework. It's just about getting something done so I know you're doing something. Yeah. Yes, they are. Make sure you look at them because there's one online right now, a practice exam. Make sure you get an idea of what's to come so you know what you should be preparing for. It's a version of an exam, by the way. It's not the exam. Something from it may be on the exam. Something from it may not be on the exam. Okay. All right, finally, let's go through this appendix. How do taxes affect equilibrium prices and quantities? So supply and demand analysis is also a useful tool for analyzing the effects of various taxes. In the next section, we consider a constant tax per unit of output, which is called an excise tax. A tax charged on each unit of a good or service that is sold. That tax is the same regardless of how much that good or unit costs. Versus what's called an ad valorem tax. According to value is what that means. It's a Latin term, and that is based on value. So it's a percentage tax, like most tax that we pay at the convenience store for anything that we buy. So the main question we'll consider is how will the equilibrium price and quantity of a product be affected if a tax of say $10 is levied on each unit sold by the producer, let's say. So there's two equivalent ways to approach this question. The first is to suppose that the tax is levied on the seller. So if the tax is levied on the seller, then effectively what that will do is to decrease supply. It'll shift the supply curve up. So here's the initial equilibrium. Here's the price that was clearing the market clearing price, the equilibrium price. And so suppliers were willing to supply Q star at that price. To supply Q star now, though, they will need 10 extra cents because they now have to give those 10, or is it $10, whatever it is, 10 extra units to the government. So therefore, they need to charge $10 more per unit to be able to make what they need in order to satisfy their costs. And so they will add those $10 to every quantity they supply. So effectively, that shifts the supply curve up, which essentially decreases the supply. So here is the price at the new equilibrium, which is P1, and initially that amount was willing to be supplied at a price of P1 star, that new equilibrium price, minus the 10, right? So that's the difference between every price now. So the resulting after-tax supply schedule is the original supply schedule shifted up by 10 units. The effect of the tax is to cause our equilibrium quantity to fall. The price paid by the buyer rises from P to P1 star, and the price net of the tax received by the seller falls from P1 star, falls to P1 star minus 10. So essentially, we were initially here. This is how much suppliers were getting P star. This is how much the buyers were paying P star, right? Even though the price, the tax, affected the supply schedule because it's being imposed on the supplier, the consumers also wind up paying part of that tax, right? So the amount they pay is going to be the amount of the new price minus the old price, and then the amount the suppliers are going to wind up paying is going to be they're going to wind up collecting. Before they were collecting P star, now they're collecting P1 star minus 10. So the difference between these two is the amount of tax that the supplier winds up paying, given what happens to the market and the effect on the supply curve. So regardless of so essentially what this is telling us is that even though you levy the tax on the supplier, everybody winds up paying a portion of it. So note that even though the seller pays a tax of T on each product purchase, the total amount the seller receives per unit lies less than T below the old equilibrium price. So again, like even though the tax shifted the supply curve up, the supplier now is not losing those 10, but losing the difference between the old price and what they're actually collecting, which is the price in the market minus the 10. So note also that even though the tax is collected from the seller, its effect is to increase the price paid by the buyers. Again, the difference between this price and the new price. So the burden of the tax is thus divided between the buyer and the seller. So that's called the incidence of the tax. So algebraically, the seller's share of the tax, denoted TS, is the reduction in the price the seller receives divided by the tax. So in this case, the seller was receiving P star. Now they are receiving P1 star minus 10. So the difference between that divided by the actual tax, which is $10, winds up being how much of the tax the seller ultimately winds up paying, the incidence of the tax or the share of the tax. Similarly, the buyer's share of the tax is the increase in the price, including the tax, divided by the tax. So in this case, it's going to be the new price they're paying minus the old price. So that's the increase in their price as a portion of the actual tax. So that's going to be the share of the tax that the buyer will pay. That's the incidence of the tax on the buyer. So in general, these portions of the tax depend on the shapes of the supply and demand schedule. So they depend on like the steepness of them, and the steepness of them reflects like the sensitivity of either side to changes in price, which we call elasticity, which we'll cover later on. So if, for example, supply is highly unresponsive or highly inelastic with respect to changes in price, meaning that as prices change, suppliers don't respond much to that price by changing their supply a lot. So that will generally happen when the supply curve is like very steep. So if the supply is highly unresponsive to changes in price, it'll be close to zero. So if they're very unresponsive, their share of the tax will be close to zero, and TS will be close to 1. I'm sorry, the share of the buyer will be close to zero, whereas the share of the tax will be close to 1, meaning that the suppliers are unresponsive to changes in price, and therefore they can afford to take on more of the tax, and they will respond less to that. Versus like if they're very responsive to changes in price, that means that the burden of the tax will fall more on the buyer, because if it fell more on the supply, then the supply would reduce quite a bit. Conversely, if demand is highly unresponsive, so if demand is inelastic, so then the share that the buyers will wind up paying of the tax will be closer to 1. They will pay a higher portion of the tax. The burden of the tax, the incidence of the tax will be higher for the buyer. And TS, the share of the tax the supplier pays, will be close to 0. So a second way of analyzing the effect of a tax of $10 per unit of output is to imagine the tax is collected directly from the buyer. So in this case, DD is the resulting after-tax demand curve. Essentially, what happens is that at any given quantity, now they have to pay more. They have to pay more, and so effectively, what happens is like demand decreases, right? Whenever like essentially, what this essentially is doing is affecting the real income of the buyer, the amount they can buy in real terms, the actual goods they can buy, and so when that happens, demand decreases. So that's effectively what is happening here. So the equilibrium quantity falls from Q1 star to Q2 star. So again, we have that fall in equilibrium. And the equilibrium pre-tax price falls from P star to P star 2. So when that happens, again, the equilibrium price will fall. The total price paid by the buyer after imposition of the tax rises to P star after the imposition of the tax rises to P star 2 minus 10. So again, this is the original equilibrium. This is the new equilibrium. This is the price that the buyer will pay, but they also have to pay $10 in tax. So this is the actual price that they will wind up paying. So the effect of a tax on the seller is no different than the effect of a tax on the buyer. In the end, they're each going to have to pay a portion of that tax depending on, regardless of who is the one directly being taxed. So again, here, the supplier's tax, the supply decreases. Here, the demand consumer is taxed, so the demand decreases. And in both cases, neither party has to pay the full tax. In this case, the price the supplier was collecting was this. Now the supplier is collecting this price, so what they're collecting has gone down by some fraction. And before the consumers were paying this much, and now consumers are paying this much, so that what they're paying has gone up by a fraction, but the actual tax is the difference between these 2 points. So that is divided between the two. And the point of this whole thing that I just talked about is just to understand that an excise tax will shift the curve depending on if we're talking about the supply or the demand side, and that the actual burden of the tax will be divided between the seller and the buyer. So that's what I would need you to understand just theoretically in general. But let's look at how a tax will affect the market equilibrium algebraically via just expanding the last problem that we were looking at. So the key to understanding how to incorporate a tax is to know A, who's being taxed, and then B, how to introduce that into the system of equations. So in this case, the Santa Cruz City Council wants to raise more revenue. Again, we're dealing with the same problems, so the same inverse demand and inverse supply function. The Santa Cruz City Council wants to raise more revenue and imposes a tax of $2 on every taxi ride collected from the taxi cab company. So effectively, the supply curve is going to shift to the left, right? They are being taxed by $2. So then the question is, what is the new equilibrium quantity? All right, so effectively, at the old equilibrium now, to supply that same amount, suppliers will need $2 extra because they have to pay those extra dollars. So there's our tax supply curve that shifted up. So we're looking for this new equilibrium quantity here. All right, so here is our system of equations. Can somebody tell me how to incorporate the tax into this system of equations? The supplier is being taxed $10. We don't know it. We don't know the new equilibrium price. We just know there's a tax of $10. So we know it's going to be on the supply side, right? So we know that we have to incorporate it into our supply, in this case, inverse supply function. How do we put it in there, though?
So every time you buy one, you subtract $10.
Right, exactly. So people are going to pay the supplier P, right? The equilibrium price. And then the supplier is going to need to pay $10 to the government, right? So what is going to happen to P there? Minus 10. We're going to subtract 10 from what the seller is going to get. So that's how you incorporate a tax on the seller side. You subtract the tax from the seller. So by doing that, when we add this 2 to both sides to incorporate into our equation, we know that that's going to shift our equation up by 2 units, right? That's exactly what happened to supply. It shifted up, supply decrease. So this is our new tax inverse supply. So once we have that, we then just do what we normally do to get an equilibrium. We interact this new supply curve that's been shifted up by 10 units. I'm sorry, it was 2 units. I got that mixed up. Anyway, you understand. Our inverse supply function, we interact this with our demand function to get the equilibrium. So again, just plugging this in to here, the P, doing some math there. I'm going to go quickly here. Will get us to our equilibrium quantity. Make sure you do this at home and work it out. So that's our equilibrium quantity of 1172 as a result of the supplier being imposed an excise tax of $2 per unit. What is the equilibrium price? Well, you just plug in Q star into either of this equation and this one, obviously not that one, because we're no longer dealing with the old supply schedule. We're dealing with a shifted supply schedule due to the excise tax. So 11 plus 0.00833, we plugged in our Q equals 1172, and we get the new equilibrium price to be 2076. Suppose a tax of $2 is imposed on the buyer instead of the seller, though. What is the new demand function? So how are we going to get it into here? So think about what was happening with the buyers. They were paying an equilibrium price, and then they were taxed an extra amount, right? So what was happening to the price they're paying? By the tax, right? So therefore, how do we incorporate that tax here into our demand function? Say it again. Yes, over here, we have to add the $2 to the price that's being paid by consumers, right? So you have to make sure you do it within parentheses because it's just the price that's being added, not the slope. The slope isn't being affected. So you add that there, and then You incorporate that by distributing this out, and then you subtract 48,000 from 51,000 to get our new our new demand function, which is the tax demand function. What's the new equilibrium price and quantity? Well, now we just do our system of equations. Remember, this is the old inverse supply function. So now you just do what you do, right? Plug this in there, do a little algebra, get to the equilibrium price to be 393,846. Divided by 20.992 gets you the equilibrium price of 1876, equilibrium quantity of 1176. And so again, we wind up with the same price. We wind up with the same result. And that's how you do it algebraically. And we are done with chapter 2. Congrats, folks. I will open up the chapter. Make sure you practice the problems. I'll open up the mini paper as well. And have a great weekend. I'll see you on Tuesday. If you're trying to get into the class, make sure you sign in.